In this video, we're going to be talking about naming compounds. And we're going to talk about transition metals. You'll notice I have a star here. This can be one of the more difficult ones to do. I'm going to try to give it to you as easy as I can along the way, but make sure you watch very carefully. Now, going back to one of the charts we've used in one of the other videos, transition metals are the middle section of the periodic table. You'll notice we have all these rules for the tall columns. 1 valence all the way down, 2 valence all the way down, 3, 4, 5, 6, 7. Or we talked about charges in the last video, +1 all the way down, +2. We keep skipping this middle section. These are the transition metals. They just don't follow the normal rules. So we're going to deal with them now. So anything that is on this chart that goes from scandium to the stair step, these are all transition metals. Sometimes even includes these, because remember, these fit inside that section. Okay, these are called the transition metals, and the transition metals give us a little bit of problem. So let's take an example and see how it works. Let's take something like copper and oxygen. The weird thing about transition metals is they can change charges. They can change their charges. They're not always the same. Now, this is the part I will know that you won't know, but I'll just help you here. Sometimes copper can be a 1, and sometimes it can be a 2, depending on what it does with its electrons. Now that may seem really weird, but just being generic at this point, that's how it works. Transition metals can move their electrons around in such a manner that they can one time have one charge and another time have another charge. Now, oxygen on the chart is in the -2 column, so it's always a -2. Now if I do what I've been doing in the other videos, the answer for this compound when I switch them is Cu2O, and this one is CuO. They cancel. This one would be called copper oxide, and this one would be called copper oxide. But you can't have two things that have the same name in different formulas. And so they had a real problem. Now if you think about this for a minute, let me give you a real life example for this. Copper oxide, this one right here is what the Statue of Liberty looks like. The Statue of Liberty has reacted with the air in the New York area, and it's got that greenish color to it. That's what this copper compound is. This copper compound is actually what a penny looks like that you pull out of your pocket. A brand new one, shiny copper colored, but they turn brown over time. These are both copper compounds, but they don't look the same. So if I told you I had copper oxide, you don't know which one I'm talking about. So they had to come up with naming so that you knew which one. So somebody who was real smart just said, well, you can't tell by looking at the periodic table what copper's charge is, so what we're going to do is we're just going to tell them in the name. And so they're going to use Roman numerals to help us. Okay, so you have to know your Roman numerals, so let me walk through that real quick. Roman numeral 1, 2, 3. Roman numeral 5 is this. Now why would I jump 4? Okay, when you do your Roman numerals, so 1, 2, 3, 1 before 5, that's 4. Okay, so V is a 5. If you had 6, it's 5 and 1 is 6, so this is 1 before 5, that's 4. 5 is just V. V1, that's 6, that'd be 7, that'd be 8. Okay, so you have to know your Roman numerals a little bit. So if we look back, what was copper's charge? So this is called copper 1 oxide. So the name, it actually tells you its charge. Why? Because you can't tell by looking. Copper had a 2 charge right here. So that's copper 1 oxide, copper 2 oxide. Now, you may look at it and think, well, why did you say that's hard? That's pretty easy. Well, notice this. Copper 1 oxide tells me its charge, not how many are inside the formula. What was its charge? Okay, so let's try another one. I know that iron can sometimes be a 2. I'll just put it with oxygen to be simple. And iron can sometimes be a 3. If I get this one correct, it's FeO, and this one's Fe2O3. This one's rust. That one's rust. When your bicycle rusts, you know what rust looks like. Okay? And this one is when a piece of iron, when it starts looking dull and you can rub it and that black stuff comes off, that's this iron oxide. Okay? So this is called iron oxide, and this one's called iron oxide. The difference? Well, iron is in the middle of the chart. So here's the deal. Every time you have a compound that starts with one of these in the middle, you're going to have to use Roman numerals in the name. So go ahead and write that down on your periodic table somewhere. Anytime it's this middle section, you have to put Roman numerals because you don't know the charge. So this was iron 2 oxide, and this was iron 3 oxide. Again, it's the charge to make the compound. Now, why does it work like that? Well, let's say it's not oxygen. If I get ahead of you on any of this, pause and then catch back up. Let's say it was with chlorine. Well, chlorine on the chart's -1. So this one would be FeCl2, and this would be FeCl3. Iron is still a 2, but it would be called iron 2 chloride. And then this one would be iron 3 chloride. So the name is telling you what iron's charge is. Okay, so it works like that. What if it's not just a single element? Let's say it's something like nitrate. Works the same way. Nitrate. That's one of those on the back of the periodic table that you have to know. So anytime you say 8 or ite, you go to your polyatomics on here and you use those. Okay? So when I switch them, it becomes Fe parentheses NO3 2, and this one is going to switch out here, so I'm going to have NO3 3. So this becomes iron 2 nitrate. Notice what hadn't changed, the 2, because it's still a 2 charge. Iron 3 nitrate. Works with any of them. It works just like the other ones. The only difference between the last videos and this one is you have to have a Roman numeral in the name. Now, let's do the reverse real quick. Let's say you had, let's use this one that we just had and see if we can get the name back. Here is where it's tricky. Watch very carefully. Fe is iron. NO3, look it up on that chart, is nitrate. We're doing great so far. But since iron is in the middle of the chart, we know that it has to have a Roman numeral in the name. How do I know the Roman numeral? And I come up with the following idea. If I cut the molecule in half, the front half is positive and the back half is negative. One of these I do know the charge of. I know that NO3 is a -1. So if I had 3 of them, -1, -1, -1, all together, that's a -3. So if the back half has to be a -3, the front half has to be a +3 because they're supposed to equal 0. So I just did the reverse process one more time. Nitrate's -1, and there's 3 of them. -1, -1, -1 is -3. I just figured out it's iron 3 nitrate. So I cut it in half and figure it out. Let's try another one real quick. What if I had one like this? ZnCl2. So I'm going to have to train myself to start looking. ZN's right there. Transition metal. Okay, so I know it's zinc. Have to have that in the name. Chloride. How do I get the Roman numeral? Cut it in half. Chlorine is, let's see, what charge? Chlorine is -1. And there's 2 of them. -1, -1 is -2. So the front half has to be a +2. And there's only one of them here. So the zinc was a 2. Now, if I can take it and check my work. If zinc was a 2 and chlorine is a -1, when I switch them, I got the answer back. So I can check my work. So zinc had to be +2. One more, and then I'm going to have you try one on your own. What if I had this one? This is probably one of the hardest ones, so watch carefully. I know it's iron. I know the last word is oxide. Cut it in half. Oxygen is -2. And there's 3 of them, -2, -2, -2. That's -6. So I'm multiplying. So the front half has to be a 6. Now you would think immediately it's a 6. But look right here. There's 2 irons that have to add up to 6. So that means each of them is a 3. So let me say that again. If oxygen is -2, -2, -2, multiplying, -2 times 3 is -6. 6 divided by 2 parts. Each iron was a 3. Check my work. Fe, if it's a 3, because it tells me it is, oxygen's a -2. Check my work. When I switch them, do I get Fe2O3? I got my answer back. Has to be the answer. In the next video, you'll try a couple on your own.